In this problem, we need to verify that the three lines whose equations are given to us are concurrent, provided A, B, and C are in arithmetic progression. Okay, let us begin. Now, we'll start with the given condition, that is A, B, and C. These three terms are in arithmetic progression. Now, we know that whenever three numbers are in arithmetic progression, then we can take the second term and subtract the first term from it. This difference is going to be exactly the same as taking the third term and subtracting the second term from it. So here we get b minus a equals to c minus b, or in other words, we get 2b equals to a plus c. We're going to label this as number 1. We're going to use this. Now what we'll do, we have three lines. We have the line L1 with equation ax plus 2y plus 1 equals to 0. Then we have the next line L2 with equation bx plus 3y plus 1 equals to 0. And then we have the third line with equation cx plus 4y plus 1 equals to 0. So what we'll do, we're going to form a 3 by 3 determinant. So in this 3 by 3 determinant, we have three rows, R1, R2, and R3. So in row number 1, we're going to consider the coefficient of x and y of line 1, including the constant term, which is 1 here. So we have a, 2, and 1 in the first row. Then in the second row, we're going to consider line number 2. So we get the elements as b, 3, and 1. And then in the third row, we consider the line L3. So we get c, 4, and 1. Next, what we'll do, we're going to expand this determinant about the first row. So a is going to get multiplied to the 2 by 2 determinant, which can be obtained by rejecting the row and the column that contains the element a. So we have 3, 1, 4, 1 minus 2. So 2 is the element that we picked from the first row, second column. This is going to get multiplied to a 2 by 2 determinant, which elements 4, 1, c, 1. So here we have rejected the row R1 and the row RC2 because that contains the element 2. Then we have the term in the first row, third column, so that's 1. 1 gets multiplied to B3, C4. Right. So let's further simplify. We have A multiplied to, so 3 times 1, that's 3, minus 4 times 1, that's 4, minus 2 multiplied to, so B times 1, that's B, minus C times 1, that's C. Added to, so we have b times 4, so that's 4b minus 3 times c, that's 3c. So what that was going to give us, so 3 minus 4, that's negative 1, negative 1 times c, that makes it negative a. So negative a minus 2b plus 2c added to 4b minus 3c. So we have negative a, so negative 2b and positive 4b becomes positive 2b. Then we have positive 2c and negative 3c, so that becomes negative c. Now since 2b equals to a plus c, we now have in place of 2b, we're getting a plus b, and we already have negative a and negative c as the terms present. So they get, this is a plus c, so a, all the terms get cancelled, leaving us with 0. So we have shown here that the determinant equals to 0, which proves that these three lines are going to be concurrent. So we can say thus, the three lines L1, L2, and L3 are definitely going to be concurrent in nature. That means they are going to pass through a common point, provided A, B, and C are in AP. That means in arithmetic progression. Hence proved.